No, it should be fine. Hey, everybody, we're just going to wait a couple more minutes for everybody to get on. If you could get your names ready and your videos ready, we're just going to give everybody else a couple more minutes, okay? Did you have a question, Maggie?
No, I just touched the icon and then like.
Okay, why don't we get started? So, oops, gotta get Ryan in here. So the first thing we're gonna do is look at any homework. Did anybody have any questions on the homework for this week? I'll post the answer sheet today. but I just wanted to see if anybody had any questions or any they got stuck on. No? Okay. Perfect. Well, we're going to look at a couple of them, or 3 of them. So I picked, let's see, number 32. So we're going to do number 32, number 58, and 57. I just picked some random ones here that looked pretty good. Okay. Number 32 from page 41. At Union Station, you notice that 3 subway lines just arrived at the same time. The table shows their arrival schedule. How long must you wait until all 3 lines arrive at Union Station at the same time again? So did anybody know how to do this one? Did anybody get this one? No? Okay, perfect. So this will be a good one that we can go through, right? So we have to figure out at what time or how long we have to wait until all of these comes through. So one's every 10 minutes, one's every 12, and one's every 15. So does anybody know what we're trying to find here? Go ahead, Jerry.
The least common multiple of all 3 numbers.
Perfect. So we're looking at the least common multiple. So we're trying to figure out when all of these will meet up again, at what number. Did you have something to say, Nicole?
I think the least common multiple will. Wait. Oh, never mind. Sorry.
Okay, no worries. So when we're looking at least common multiples, we know this will be an easy one because we know this has 10. So our least common multiple will have to end in a 0, right? So 10 will be our good starting point. So what numbers, 12 and 15, can we multiply these by to get a 0 at the end? So anything we multiply 15 by, that's an even number, say 2, 4, 6, 8, or 10, will give us a 0 at the end. So how about for 12? What can we multiply 12 by that'll give us a 0 at the end? Does anybody know? Go ahead, Jerry.
5 or 10.
Perfect. So we'll multiply this by 5 or 10 to get a 0 at the end. So when we're looking at these, this makes it a little bit easier to solve, right? So we'll start off with just the easiest one, 12 times 5, which equals 60. So can 15 times any of these numbers equal 60? Go ahead, Jerry.
15 times 4 equals 60.
Perfect. So 15 times 4. And now we have to go back to our 10. Is there anything we can multiply 10 by to get 60? Go ahead, Nicole.
Into the 10 times 6.
Perfect. So 10 multiplied by 6 will also give us 60. So in 60 minutes, all 3 trains will come by again. Does that make sense for everybody? Awesome. Anybody have any questions on that one? Perfect. Oops. Hang on. This one actually, this one was actually from this week's homework. So I had the wrong one. Sorry, I got one ahead. So that's what this week's homework will look like. That was my fault. Picked the wrong one. Okay, so we'll skip the homework. Does anyone have any other questions about homework though? No? Okay. So this one, you guys got a good look into next week's homework, I guess. All right, so we'll get started on our lesson today. So today we're looking over fractions, least common multiples, and I think that's it. Multiplying fractions. So it'll be all basically just fraction stuff again. So, yep, go ahead, Maggie.
Will there be like converting fractions into decimals or no?
Not in this one, there won't be. This one we
Okay.
will be, let's see. I don't believe that was any of that. We'll just be like adding, multiplying, subtracting, dividing, doing least common multiples, mixed numbers, reciprocals, order of operations with exponents, and dividing whole numbers by fractions. So no decimal conversions today.
Okay, thank you.
Yep. Okay. So a fraction, like it says, is the quotient of two rational numbers. Okay. So we know fractions, right? 3/4, 6/9, 10/100, right? So we have our numerators on top and our denominators on the bottom. And so when we're looking at fractions, they're actually quotients. So these are actually like 3 divided by 4, right? It's just an easier way to write it versus decimal. Like, right, Maggie? Fractions are a little nicer. They're easier to work with. So least common multiples. Our core concept is multiples that are shared by 2 or more numbers are called common multiples. The least of the common multiples is called the least common multiple. We can find the least common multiple of 2 or more numbers by listing multiples or using prime factors, right? So we're going to find the least common multiple using the list of multiples. So for example, here it says, find the least common multiple of 4 and 6. And so, like it says here, we can list multiples. And so we can do 4, and then we can do, let's see, 8, 12, 16, 20, 24, 28, 32, right? Same with 6. We can do 6, 12, 18, 24, 30, 36, and then so on, right? We can keep going. But when we're looking at the least common multiple, we want the lowest multiple that both numbers go into. So if I'm looking at this one, Alina, would it be 24? Because it's in both of them?
No,
And why not?
because it's not the least common multiple. It's only a common multiple.
Perfect. So then what would our least common multiple be, Alina?
12.
12. Perfect. So we have a smaller one than 24, which is 12. And so least common multiple of 4 and 6 would be 12. Great job. Okay. Brian, can you do A for us here? The least common multiple of 3 and 8. Nicole,
Okay.
we're going to have you do B. 1 second, Brian. Nicole, I'm going to give you B. And Maggie, I'll give you C. Okay? All right, Brian. And everybody else, you can do these too. Brian, whenever you're ready, you can start us off.
Okay, so I'm ready.
Okay, go ahead.
The least common multiple of 3 and 8 is 24.
24. And how did you do that?
I use a prime factorization.
Okay. And so you did the prime factorization of 24?
I think I should have used the least common multiple because it says so.
That's okay. So tell us how you did this one, Brian. Walk us through it. Since you did it the other way.
2 times 2 times 2 times 3. Oh.
Times 3, like that.
Uh-huh.
And so then you just multiplied them all through.
Uh-huh.
Perfect. And got 24. And that's it.
Mm-hmm.
Easy enough, right? Not too hard. Okay. Nicole, would you like to do B now?
I prefer using prime factorization.
The common multiple of 9 and 12 is 36.
36. And how did you do that one?
I use the least common multiple. So like 9 times 1 equals 18. 12. 9 times 2 equals 18. 12 times 2 equals 24.
Perfect.
9 times 3 equals 27. 12 times 3 equals 36. 9 times 4 equals 36. So
Perfect.
the common multiple is 36.
Awesome. Great job, Nicole. Thank you. All right. And then we had, oops, who did I give the last one to here?
Can you give it to someone else than me? Please.
You don't want that one, Maggie?
No.
Okay. Jerry, you got this one then. Switch it up, Jerry.
So I did it the prime factorization way.
Okay.
So 6 can be broken into 2 times 3, 2 and 3.
Just 1 second here. So we have 3 times 2.
Yeah, and then 10 can be broken into 2 times 5.
And then 5 times 2. Perfect.
And then we only use we use 3, 2, and 5.
Okay. 3.
Multiply them together, and then we can find the least common multiple.
Perfect. So we got 30. Perfect. So why didn't we use this other 2 then?
Well, because because we already, I don't know.
So I think it's when we're looking at it, when we're breaking these down, I usually just do the list way. I find it easier just for me, and I find it faster because I know 6 and 10, right? 6 times 5 is 30. And so 10 easily times 3. But I think if you're looking at this, if you do 3 times 2 times 5 times 2, then we'll get 60, right? Because that'll just be 6 times 10. But we know that 60 isn't the least common multiple. So that's when we just take out this one. So we'll divide it by 2. Great job, Jerry. All right. So now we're looking at prime factorization. So we're going to find the least common multiple of 16 and 20. Do you want to try this one, Jerry?
Okay.
All right.
So I did the prime factorization.
Perfect. So that's what we're going to do for
16
these
and
ones.
20. So 16 equals 2 times 2 times 2 times 2.
Okay. So we got 2, and then we had 8.
Yeah.
And then 2 and 4, and
And
2 and 2. So we got 2 to the 4th.
And then 20 can be broken into 5 and 4.
5 and 4, 2 and 2.
And then the equation would be 2 times 2 times 2 times 2 times 5.
2 times 2 times 2 times 5.
And so because 2 appears more times in the 16 than in the 20, we use all of the 2's in the 16.
Okay.
It should be 4 2's, I think.
4 2's. I missed one.
Yeah.
So 2 times. All right.
And
So we got 1, 2, 3, and 4. Okay.
And then in 25 only appears once, and we've already circled used the 2's from the 16, so we don't need to use the 2's from 20 again.
Perfect.
And then so we just have to multiply and get the answer.
So whichever side has the more 2's, those are the ones we use. Correct? Perfect. So we'll get 2 times 2 times 2. So we get 8. 2 to the 4th is 8 times 5. And what do we get, Jerry?
2 to the 4th should be 16.
2 to 16. Yes, 2 to the 3rd is 8. My bad. There we go.
8.
That looks better. And so we got what?
5 is 80.
80. Perfect. And so we could tell it's 80, right? because we can do 20 times 4. And so if we did 20 times 3, that's 60. 16 doesn't go into 60. 20 times 2 is 40. 16 times 2 is 32. So we know that wasn't going to 40. So 80 would be our answer. Great job, Jerry. All right. Let's see. Does anybody want A for this exercise? All right, Nicole, go with A. Let's see. Alina, we'll go with B. Let's see. Kevin, do you want to try C?
Okay.
All right. Then we'll go Kevin right here. All right, we'll give everybody a minute, and then whenever Nicole's ready, you go ahead. Are you ready, Nicole? Okay, let's go ahead.
So I used prime factorization.
Okay, perfect.
First, I break down 14 into 7 and 2.
Perfect.
And I broke down 18 into 9 and 2. And I break down 9 to 3 and 3.
Perfect. Okay, and then what?
And then I did 7 times 2, which is 14. And then 14 times 3, which is 54.
Okay.
54. Then I did 54 times 2, which is did 54 times 2, which is 108. And then I did 108 times 3, which is 324.
Okay. And so that was your final answer is 324.
Yeah.
Okay. I want to say, let me see, 324. Okay. Perfect. And so I think that's it, right? 324. 14 times 3. So I think we messed up right here. 14 times 3, I think, is 42. And then times 2, it should be 84. And then we times it by 3. And we would get 252, I believe. Go ahead, Jerry. What's that?
My answer was 126. We're only supposed to use the 2 one time, not 2
Right.
times.
That's what I was thinking too. Do you see that,
Yeah.
Nicole? So when we're breaking down, when you got your prime factorization, you got 7 times 2, and then we got 3 times 3 times 2 for our other side. We only use 1, 2. Since we have a 2 on each side, we only need 1. So we can cross 1 out, like Jerry said. Whichever side has the most 2s, or say if both sides had 2 3s, we would only use 1. Whichever side has the most. So we can cross 1 out. And then when we multiply these numbers, we'll get half of 252. Which, what did you say it was?
126.
126. And that would be our least common multiple. Does that make sense, Nicole? Does that make sense for everybody else? Does anybody have questions on that?
No.
Okay, perfect. All right, Alina, 28 and 36.
So I broke 28 apart by doing 4 times 7. Then I broke the 4 down by doing 2 times 2. I
Okay,
broke the 36 down by doing 6 times 6.
all right.
I broke the 6 down with 2 times 3.
Like
And
that?
then, yeah. And then I did 9 times 2 times 2 times 2 times 3 times 2 times 3.
So
Which is,
you used all the 2s?
no.
How many
I
2s did you use?
I use like for the 28 there's 2 2s, and for the 36 there is 2 2s. So I used them all and then made them into 2 2s.
So I don't think we'll need these 2, right? Because if we have 2 2s over here and 2 2s over here, we should be able to take these 2 and not use them, right? Because we only use the majority. So
Yeah.
it should just be 7 times like 3 squared times 2 squared, correct?
Yeah.
Is that what you ended up getting? You only used 2 2s, you said?
Yeah.
Okay, sorry. I must have misunderstood you. So then what was your final answer here, Alina?
My final answer was 252.
252. Okay. Perfect. That's what I got too. Does that look good for everybody else? Anybody have questions on that one? Awesome. Great job, Alina. Thank you. Maybe that's why. Okay. Let's see. And then we have Kevin bringing it home with the last one. All right, Kevin, walk us through it.
So I first split up 24. So it equals so I split into 4 times 6, and then I split the 4 into 2 times 2, and then the 6 into 2 times 3.
Perfect.
So then, and then I split 90. So 90 it equals to 9 times 10. And then so 9 can be split into 3 times 3, and 10 can be split into 2 times 5. So if you organize it, then yeah, and then I put them, and then I put the two equations on top of each other.
Okay. Like that? On top of each other?
I would rather my method is to is to arrange them from the smallest number to the biggest number.
Okay.
So for the bottom equation, I'll do 2 times 3 times 3 times 5.
Got it. Like this?
Yeah.
Okay.
And so then in each equation there's a 2, so I just connect them.
So what do you mean you connect them?
Well, I just when you stack them together, they're common, so you just circle them.
Okay, so you want to circle all the 2s? So we got to remember though, if this one up here has 3 2s, it has the most of that prime number. So
Yeah.
we won't use this 2.
Oh. So
If that makes it easier.
yeah, so then I circle the 3 2s on the top equation.
Yep, so then we'll use these ones.
Yeah, and then for the bottom equation, it has 2 3s.
Yep.
So since it has the most 3, I circle that one too.
Perfect. So we'll use these 3s
Yeah.
and we'll cancel this 3 out.
Yeah, and then for 5, there's only one 5 in. Yeah, so I just put it in the equation. So I did 2 times 2 times 2 times 3 times 3 times 5.
Perfect. So I just wrote this is 3 squared, right? And this is 2 to the 3rd.
Yeah,
It's 8 and
so
9 respectively.
that would be 8 times 9 times 5 equals 72 times 5 equals 360.
Perfect. 360. Awesome. And then we can check it, right? 360 divided by 24 is 15. And 360 divided by 90 is 4. So we know that both numbers go in. And I believe that's right. Awesome. I don't think. Yep. Great job, Kevin. Great job walking us through it too.
Yeah.
I appreciate it. Great job, everybody. All right. So now we're going to go on the least common multiple of 3 numbers. So now we'll have 4, 15, and 18, right? Jerry, you want to walk us through this one again?
So 4 can be broken into 2 times 2.
Okay.
15 can be broken into 3 times 5.
Okay.
18 can be broken into 2 times 9, and then 9 can be broken into 3 times 3.
2 times 9, and then 3 times 3. Perfect.
And so 18 has the most 3s, so we won't use any of the other 3s. 4
Perfect.
has the most 2s, so we won't use any other 2s. And there is only one 5, so we're going to have to use that 5. And so my final answer was 180.
So 180. So you got 9 times 4, right? times 5, 180. Perfect. That looks good to me. 180. So does everybody see how Jerry did that one? That one was kind of quick. Does anybody have questions on that one? Okay, so just so everybody knows, I'm going to walk you guys through it again. Jerry did it really quick. It was perfect. So he took the 4 and had 2 and 2. 15 is 5 and 3. And our 18 is 2 times 3 times 3. But since we have the most 3s in this one, we're not going to use the 3 from the 15. And since we have the most 2s in this 4, we're not going to use the 2 from the 18. So what we're left with is our 2 2s, our 5, and our 2 3s. Does that work for everybody? Does that look good? Thumbs up. All right. Here we go. So find the least common multiple of the numbers. So A. Maggie, would you like to try A for this one? No. Max,
It's
would you like to try
confusing.
A?
Like it's kind of confusing because
Okay, well, I'm going to give you this one, Maggie, and we'll walk through it, okay? I'll walk through it with you. I'm going to let you try it, and then we'll walk through it. Does that sound okay? All right. Max, would you like to try B?
Next time.
Next time? Okay. We're going to work on you. Let's see. Brian, would you like to try B? I don't think you've gotten to go.
Okay, so
Okay. So this will be Brian. In 1 second, Brian. And then Amber, would you like to try C?
Sure.
Okay. And we'll go Amber here for C. Oops. All right. So I'm going to give everybody a minute or two to do those. Okay. And then we'll come back and we'll do them all together. All right. So if everybody can practice those to make sure we're getting the right answers.
这个下完课了你再做，你上课就好了，就这个。
下完课我们还有中午，只有我们4点以后。
人听得到你们呢。
Okay. Are we ready, Maggie? Not yet. If you want, I can walk you through it too. All right. We can walk through it
Yeah.
together.
You went through it really fast. I mean, I couldn't actually get all the details that well.
That's okay. That's why we'll walk through it together. I'll walk through with you, okay? So
Okay.
we'll start it off, okay? So let's do this. 2, 5, and 8. So do you want to do it the prime factorization way, or do you want to do it the list way?
List, please.
Okay. So we'll do that. So we'll do 2, 5, and 8, right?
Mhm.
So we start off, if we're doing the list, we'll list the common or multiples of 2, right? So 2, 4, 6, 8, 10, 12, and it'll keep going, right? So we'll look at 2 later because this one's so small. So now let's look at 5 and 8, right? Since these ones are bigger, our common multiple, or least common multiple here, should be even, and so 2 should go into it. So let's do it. 5, common multiples of 5 are 10, 15, 20, 25, 30, 35, 40, right? And then multiples of 8, we got 8, 16, 24, 32, 40, 48, right? So with this information, can you give me the least common multiple of 5 and 8?
Let's see. 10?
So 8 doesn't go into 10, right?
No.
So we want to find multiples. So we got to find something that both 5 and 8 go into.
Okay. 40?
40, right? Because that's our lowest number that's on both of these lists is 40, right? So our least common multiple we know of 8 and 5 is 40 because we can look at the list and that's the smallest number that both of those go into, right? Does that make sense?
Mm-hmm.
So then now we have to look, since this has 3 numbers, does 2 go into 40?
Yes, actually, but farther. But
Yes. So
but
we'd
it's
have
not
to
the
go
lowest.
right. It will be the lowest for these 3 numbers, right? So
Mm-hmm.
if I asked you what the least common multiple of 8 and 2 was, you'd just say 8 because 8 or 2 goes into 8, right?
Mm-hmm.
But if I asked for the least common multiple of 5 and 2, it would be 10. But since we have all 3, we're bounded by this 8 and 5. So whatever these ones have, it'll be the lowest because it'll have to be an even number and 2 goes into even. So it would be 40. It's down here down the road.
Okay.
And so if we're doing it the prime factorization way, 2 is an easy one, right? Because that's just 2. So when we're breaking down 2, we'll have 2 and 1. But since we multiply it by 1, it doesn't matter because it's the same. And then we can break down 5. And what can 5 be broken down into, Maggie?
1, 5.
5 and 1. And we don't use the 1, right? And so now, what about 8? What can 8 be broken down into?
2, 4.
2 and 4. And then we can break down 4 again, right?
2 and 2.
2 and 2. So when we're looking at these, which number has the most 2's?
8.
8. So it has 3 2's. So we can come over to this factorization, and we're going to cross this 2 out because that's not going to be involved in our equation to solve it, right? We'll take that 2 out. So now, are there any 3's in here? Right? There's no 3, so we don't have to worry about it. So now our only other number is this 5. And is there any other numbers with 5 in them?
No.
No. So we know that this 1 5 will be used and that these 3 2's will be used, right? So we're left with this 2 and these 2. So we'll have 5 times 2 to the 3rd. And so what does that equal, Maggie?
It's 30.
Nope. So what is 2 to the 3rd? So 2 to the 3rd is 2 times 2 times
Yeah, that equals
2.
6.
Nope, try again. What is 2 times 2?
2, 4, 6. Oh, that's what you. Yeah,
So
8.
it's not 2 times 3. It's 2 times 2 times 2.
Okay. So,
All right.
Then 8.
And so now we have 5 times 8, right? And what does that equal?
40.
40. So here we go. So now we kind of see it in both ways, right? So you got 40 for both, and that's our least common multiple. Does that make a little more sense to you now? Awesome. Perfect.
Thank you.
Yep, no worries. Okay, Brian, for part B, 6, 10, and 12.
Okay, so what I got was 60.
So you got 60. And which way did you do it, Brian?
Prime factorization.
Okay, so you took 6, and you had 3 times 2. And then
And 10
10,
can be broken down into 2 and 5.
5 times 2. And then 12.
And 12 can be broken down into 2 times 2 times 3.
Perfect. Okay, and so You crossed out these 2's,
Uh-huh.
2 and 2,
Uh-huh.
and then crossed out 1, 3,
Uh-huh. Yeah.
right? So then you were stuck with 5 times 3 times 2 squared, right?
Uh-huh. So that
Now-
equals 60.
15 times 4 is 60. Perfect. Great job, Brian. Okay, and now Amber for part C. Write a set of numbers whose least common multiple is 100. What did you get, Amber?
So the easiest, 10 and 100.
So 10 and 100. Perfect. 10 and 100. Perfect. That's an easy one. Did anybody else get anything else? Jerry, what'd you get?
I did it with 3 numbers. I had 4, 25, and 20.
4, 25, and 20. Perfect. So that one works too. That's great. Did anybody else have any? Alina, did you have one? Nicole, you had one?
I did 10 times I did 5
Did-
and
5.
5.
So you had 2 5s?
Yeah, and then
So you could have added a 5 to this one, right? 5, 10, and 100, because it still has to be into 100. Or you could have 25, 10, and 100. Or you can have 20, 10, and 100. Anything with 100 would be fine. Or anything like this would be fine. There's plenty. There's infinite. So many amounts. All right. So now we're going to look at real life. Or does anybody have any questions so far? Or is everyone feeling pretty good? Awesome. All right. So real life application. A traffic light changes every 30 seconds. And another traffic light changes every 40 seconds. Both lights just changed. After how many minutes will both lights change at the same time again? Anybody who hasn't gotten to go want to do this one? Max, you want to try it?
Give me a second.
Yep, no worries. We'll let you work it out.
I think they will change in 120 minutes.
120 minutes or 120 seconds?
Seconds?
Seconds. And so what does that equal to in minutes?
2 minutes.
Perfect. 2 minutes. And so which way did you use? Did you list them out or did you do the prime factorization?
I'll list them out.
Perfect. And this is a nice, easy one to do it with. So 30 and 40. So we got 60, 90, 120, 40, we got 80, and 120. So that's an easy one. Great job, Max. Thank you. All right, Jerry, you want to try the second one? What if, an example, the traffic light that changes every 40 seconds is adjusted to change every 45 seconds? Both lights just changed. After how many minutes will both lights change at the same time again? Go ahead, Jerry.
1.5 minutes.
So you got
I-
1.5.
I did this with seconds first.
Okay, so you did the prime
then-
factorization, I'm guessing? Okay.
45 can be broken into 5 and 9. 9 can be broken into 3 and 3.
Okay. And then we still have 30, right?
Yeah, 30 can be broken into 3 and 10. And then 10 can be broken into 2 and 5.
Perfect. And so we cross out this.
45 has more 3's. So we cross out the 1 3 from 30. And then we just have to cross out 1 5 because both numbers have 1 5.
Perfect.
And so we just have to multiply 3 times 3 times 2 times 5.
Great. And so we
And then
get
90.
90. Okay.
And
That's
then
90 seconds.
yeah, and then we have to convert that to minutes, which is like 90 divided by 60.
Perfect. So we get 1 and 30. Oops. Yeah, 30 over 60.
Yep.
And so 1.5 minutes. Great job, Jerry. Awesome. Okay. Adding and subtracting fractions. So what's our number one rule when we have to add and subtract fractions? Does anybody know? Go ahead, Nicole.
You have to have the same denominator.
Perfect. So a common denominator, that's the most important thing. And so when we're looking at different numbers, our common denominator will most likely be a least common multiple, right? So when we're looking at this one, we get 5/8 plus 1/6. We need a common denominator for 8 and 6. So we're going to break these down, right? We can either do the list way or the other way, right? So let's do this. So we'd have 4 and 2. We know 8 is 2 to the third. 6 is 3 and 2, right? So we'll cross out this 2 and we'll get 8 times 3. We'll get 24 as our least common multiple and common denominator, right? Did you have a question, Jerry, or did you just want to answer? Okay. Do you want to take it from there, Jerry? So
Yeah.
then what do we do?
And then so we have to convert both of the denominators. Since 8 times 3 equals 24, the bottom is multiplied by 3, and so the top also has to be multiplied by 3.
Perfect.
5 times 3 is 15. And then for 6 times 4 equals 24, so the numerator also has to be multiplied by 4, and that is like 4 24ths.
Perfect. So we'll
And
end
then
up
we just have to add
getting
them.
15 over 24 plus 4 over 24. 19 over 24. Does that look good for everybody? Does that make sense? Any questions? Okay. So, Nicole, did you want to do the next one?
I have another way to do this question.
Oh, you had another way to do this one?
Yeah.
Okay, how did you do it?
So first I multiplied 4 and 8 and got 48, and then I multiplied 6 and 5 and got 30, and 8 and 1 and got 8. Then I add them together and got 38, 48, and then I see they can both get divided by 2, so I divide them by 2 and got the same answer.
Okay, so you cross multiplied, it looks like. Okay, so yeah, that works too, as long as you can see that you have to simplify it. That's the biggest thing. All right, great job. That was another way to do it. Okay, so now we're going to add fractions using the lowest common denominator. Okay, so 5, 6, oh, we did this one, right? This is 19 over 24. So now we're going to subtract using mixed numbers. All right, so we got a couple different ways we can do this, right? We can either multiply our 4 through and our 2 through, or we can pull it out and do our whole numbers and then fractions. So what do you guys like to do better? Do you like to multiply your whole number through, or do you like to do the fractions? What do you think, Jerry? What do you like to do?
It works either way for me.
Okay. Alina, what do you prefer to do?
I prefer to do to change them into fractions first.
Okay. Brian, what do you like to do? Do you like to multiply them through or just leave it?
Both ways work for me too.
How about you, Kevin? What's your favorite way?
I just like to leave it and multiply it that way.
Okay. How about you, Maggie? What's your favorite way? What works best for you?
I don't remember since it was from summer with summer bridge, but I don't remember how. I don't know, but I think it was. I don't know. Kevin might know. I don't know. He was in. I don't know.
How about you, Max? What do you prefer? Which way do you use?
I don't really care.
Doesn't matter. Okay. So I guess it doesn't, everyone seems like they can do it both ways. That's pretty good. How about you, Ben? I haven't heard from you in a while. Which way do you like to do it?
I just do whatever comes to mind first.
Okay. So sometimes you can look at it and sometimes it might be easier to do it one way than another. So here, I'll do it both ways. So I'll first do, let's see, 4 times 4 is 16. So we'll change it. We got 19 over 4 minus 2 times 10 is 20. So we got 23 over 10. 4 and 10 I know is an easy one, right? That's an easy common denominator for 40 or 20, I mean. So let's see, 19 times 5. 19 over 4 times 5 over 5. And then minus 23 over 10 times 2 over 2. So bring it down here. 19 times 5, 45 over 20 minus 46 over 20. Did you have a question, Jerry? Did I mess up?
Yeah, it shouldn't be 45. It should be 95.
Oh, whoops. It is 19 times 5. Yep, that's right. I had 9 times 5. Great job. Good call. Good call. 95. All right, there we go. So now 95 minus 46. So I got 49. Is that what you got, Jerry? Is that what everybody else got? Over 20? Perfect. So 20 goes into 49 2 times, and we're left with 9. Does that look good? Is that what everybody else got? Yeah? Okay, cool. So that's our first way to do it. And that's when we take our numbers and turn them both into fractions. The other way we can do it is we can pull it out. So we can do 4 minus 2 over here, and then have 3/4 minus 3/10, right? And so we do the same, right? We multiply this first one by 5 and the second one by 2. And so then we would get 15 over 20 minus 6 over 20 and get 9 over 20, right? And then 4 minus 2 over here is 2. So we're still get the same thing, 2 and 9 over 20, right? Does that look good for everybody? Any questions from anybody? Okay, perfect. Let's see. So now we'll work on less than, greater than, or equal to. So you guys all know the signs, right? We got less than, greater than, and equal to, right? And so I don't know how they told you, the alligator's mouth will go for the biggest one. So whichever the open end's on goes for the bigger number, okay? And some people get a little confused, which is okay. It's very common. And then we'll add or subtract. So I'm gonna throw everybody a problem. We'll let everyone do it and then we'll come back. So let's see, we'll do, let's see, Max, you got A here? Okay. Let's see, Maggie, I'm gonna give you B. Kevin, C. Let's see, Nicole, D. Jerry, I'm gonna give you A. Let's see, Melissa, B. Alina, C. Brian, you don't have one yet, right? Let's see, Brian, we'll give you D. Brian. Who else do we got in here? Ben, we're going to give you E. Amber, we'll give you F. Did I miss anybody? Does everybody have one? All right. Speak up if you don't have one. I don't want to miss anybody. I want everyone to get your practice. So what do we got? We got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay. Okay, are we ready? All right, coming to you, Max. Start us off. 4/5 or 5/6?
5/6 is bigger.
5/6 is bigger, you think. And did you check your answer?
Yes.
Yeah.
And how did you check your answer? What did you do?
The bottom
Needs to have the same denominator.
needs to have the same denominator.
Okay, perfect. So you made 30 the common denominator and then saw which one was bigger? Perfect. So you did, let's see, you had, looks like 24 over 30. And that is these times 6. And then you had, let's see, 20.
25 over.
25 over 30. Perfect. And so 5/6 is bigger because it's 25 over 30 versus 24 over 30. Great job, Max. Thank you. All right, Maggie, 5/14 or 3/8
3/8.
is larger.
Yes.
Okay. And did you check your answer?
Yes.
And how did you check your answer?
Just an easy trick, kind of, I learned from school. It's like if it's a smaller denominator, sometimes it'll be bigger. Maybe it won't be unless it's equalized. So then I kind of did just like check it and to make it the same denominator.
Okay. And so you got that. Let me just check. 5 divided by 14, then 3 divided by 8. Yeah. Nope. I think you're right. That looks good. All right. Let's see. Jerry, did you have something you were going to say? Okay. Let's see. Kevin, you got the next one?
Yeah, they're equal.
They're equal. So how did you get they're equal? You changed 24 over 10, or did you change this one?
I changed the mixed number into 12 over 5. And then I tried to make the denominator same. So 12 over 5 equals 24 over 10.
Perfect. Great job. Thank you, Kevin. All right. Let's see. Nicole, did you get an answer for this one?
Yeah.
Okay. And what did you get?
I got less than.
So which one's like this? or the other way?
Like that.
Like that? So did you check your answer? So let's walk through it. So we know these fours. These are both fours. So we'll get rid of those. We won't even look at the fours. What is our common denominator for these two?
It's 1,000.
No, even smaller. What about 100? Right? 25 and 20 both go into 100, right? And so 25 times 5 is 100. So 9 times 5 is 45, right?
Yeah.
And then 20 goes into 105 times. And 5 times 75 is 35, right? So we were a little off because that would mean, oops, or times 4. Whoops, I was wrong. Sorry, I was ahead of you. 9 times 4, 25 times 4. So 9 times 4 is 36. My bad. I was wondering why it looked weird. So when we look at it this way, Nicole, which one is larger? 36 over 100 or 35 over 100?
36 over 100.
Perfect. So we have greater than, like this. Does that make sense? Does that make sense for everybody else? Are we good? Awesome. Okay. Jerry, it looks like you got the next one. 2/3 plus 3/4.
I found the least common denominator, which is 12.
Okay.
And so because 3 times 4 equals 12, we have to for the denominator, we have to multiply the numerator by 4 as well. So it's 8/12 plus 4 times 3, which for the denominator is 12. And so we also have to multiply the top by 12, not 3. Sorry. And so it's 8/12 plus 9/12 equals 17/12, or 1 and 5/12.
Perfect. 1 and 5/12. Great job. All right. Melissa, 6 over 7 plus 1/2.
Since 6 can be divided by 2, I changed 6 into a 3 and I changed 2 into a 1. And then
So you can't do that when we're adding. That's only on multiplication and division problems.
I thought that was something different. So I did 7 times 2 and that equals 14. Then I did 1 times 7 and I did 6 times 2 and I got 12 and 7. So I added those together and I got 19 over 14, but I changed that to 1 and 5/14.
Perfect. 1 and 5/14. Great. Alina, the next one.
So for this one, I first found the same denominator, which is of 10 and 12, which is I did the prime factorization. For 10, it's 2 times 5. And for 12, it's 3 times 4. And then for the 4, it's 2 times 2.
Perfect.
And then for the denominator, I just did 2 times 2 times 3 times 5.
Perfect.
And then I got 60. And then I got 42 over 60 minus 25 over 60. And that equals 17 over 60.
Great. Perfect. Can it be simplified at all?
No.
No. Great job. All right, Brian, walk us through the next one.
Okay, so Well, what I got was, I'm pretty sure I did not use the least common multiple, but here's what I did. I did 18 times 8 equals 144, and 13 times 8 equals 104. And 18 times 5 equals 90, and 18 times 8 equals 144. So 104 minus 90 equals 14. And also 14. 104 of 144 minus 90 out of 144 equals 14 out of 144. Also equals 7 out of 72. 7 out of 72.
Okay, and then got 7 out of, what was it?
72.
72. Perfect. Okay. So you did your least common multiple, you did 18 times 8. So you just did it, just went full board with it. And that's okay. You can sometimes that's you can just do that. Sometimes you can just multiply these. You just got to know 8 goes by this one and 18 times this one, right?
Mm-hmm.
Sometimes it's easier. There's obviously 72 was your least common multiple you could have found, but that's okay. Sometimes it's okay to go the long way if that's easier for you. All right, Ben, do you want to walk us through this next one?
So, do I just say the answer or should I just?
Why don't you walk us through it? Tell us how you did it.
All right, so I converted 2 and 1/6 to 13 over 6. And converted 3 and 4/9 to 31 over 9.
Perfect.
And the least common, and the LCM of 6 and 9 is 18. So
18.
to get from 6 to 18, you need to multiply by 3. So I multiplied 13 by 3 and got 39.
Perfect.
And I multiplied 31 by 2 to get 62.
Perfect.
And then if you add them up, it's 101 over 18. And that would equal 5 and 11/18.
5 and 11/18. Oops. Where'd you go, draw? Equals 5 and 11/18. Perfect. Great job, Ben. That looks great. Thanks for walking us through it. All right, and the last one, Amber.
So first I got the common denominator is 80.
Is 80. So did you multiply these through or just leave them?
Just leave them.
Okay. So you did, what did you say it was? 80?
80, yeah.
80 plus something over 80. Okay. And so what did you
And
multiply these by?
I multiply these by, wait, so these times,
So 3 over
wait, I
16
forgot
times
to
what?
multiply them.
That's okay. Let's figure it out. 16 goes into 80, I think 5 times, right?
Yeah,
So
5
3 times 5 should be 15.
15.
And then 10 goes into 88 times, and 8 times 1 is 8, right?
Yeah.
And so then what are we left with? 23 over 80?
23 over 80.
And then 4 plus 1, right?
4 plus 1 is 5.
And that's it? 5
yeah.
and 23 over 80?
Yeah.
Can that be simplified at all? No, it can't.
No,
I was just trying to
no.
trick you. It can't because 23's odd. It's prime. Nothing goes into it. And 80, it can't go into 80. So that's all we leave it with. Awesome. Thank you, everybody. That was great. All right, so now we're going to look at multiplying fractions. I'm going to go kind of quick through this because it's pretty simple. The core concept is multiplying fractions. Multiply the numerators and multiply the denominators. And so as you can see here, when we have 3 over 7 times 1 over 2, we do 3 over 1 on the top and 7 over 2 on the 7 times 2 on the bottom to get 3 over 14. The algebraic expression is A over B times C over D, where we get A times C over B times D. B and D cannot be 0, because if we have 0 on the bottom, it is not a fraction. It would be an unknown number. So find 1 over 5 times 1 over 3. So this is easy, right? 1 over 1 on the top, or 1 times 1 on the top, and then 5 times 3 on the bottom. And that's it. Simple stuff. Okay, now multiply fractions with common factors, right? So when we're looking at this, we can see we have common factors between these, right? And so I can go across and factor out this, because 9 and 3 are factors, right? So 3 goes into 9 3 times, and that's what I'm left with, right? And 4 goes into 8 2 times, and this is what I'm left with. So this one would be 2 over 3. And how this works is when we write this out, right? When we have 8 times 3 over 9 times 4, we can flip these around, right? Since it's a multiplication problem. So we can actually have 8 over 4 times 3 over 9, which is equal to 2. Oops, this is a 9. 2 times 1/3, which is 2/3. Does that make sense for everybody? Okay, anybody have questions? All right, so I'm going to walk through these real quick. So we're looking at this one, 1 times 5 and 2 times 6. We can't cross anything out, so we're left with 5 over 12. Same here, 1 and 8 and 7 and 4. It's already in the simplest, so we would have 7 over 32. Here we have 3 and 3, so we can cross these out, and we're stuck with 2 over 7. Same here, 3 goes into 9 3 times, and 4 doesn't go into 10, but 2 can go into both of these. So 2 goes into 4 2 times, 2 goes into 10 5 times, and here we're left with 2 over 15. Does that make sense for everybody? I kind of blew through that fast, so if anybody has any questions, feel free to ask. Okay, is that good for everybody? All right. Real life application. Say you have 2/3 of a bag of flour. You see 3/4 of the flour, or you see 3/4 of the flour to make empanada dough. Empanada dough. How much of the entire bag do you use to make the dough? So I think this is supposed to say you need 3/4 of the flour. So if we have 2/3 and we need 3/4 of the 2/3, how much are we going to use? Right? We can easily do this. So I got 1/2 of the whole entire bag, because we just multiply it. Does that make sense? Does everyone see how I got that? Awesome. Okay. What if, this example, you use 1/4 of the flour to make the dough? How much of the entire bag do you use to make the dough? So you use 1/4 of the flour to make the dough. How much of the entire 2/3? Or does it want the 1/2? We just use 1/4 of the 2/3, it looks like. So it would be 1/6 1/6 of the entire bag. Right? Does that make sense? Okay. So now we're going to multiply a fraction and a mixed number. So now when we're doing this, if we have a mixed number here, now we have to take this 2 or whatever number this is and multiply it through. So 1/2 stays the same. So we'll do 1/2 times 2 times 4 is 8 plus 3 is 11. And we get 11 over 8. And this can be simplified, right? To 1 and 3 over 8. And that's the simplified version. So when we're looking at this one, 1 times 5 is 5 plus 4 is 9. So we have 9 over 5 times 3 times 3 is 9. Ooh, plus 2 is 11. 11 over 3, right? So I see 3 can be 1 and 9 can be turned into 3. And we're left with 33 out of 5. And this can be simplified. 5 goes into 30 6 times. Oops. And we have 3 left over and 5. Does that make sense for everybody? Does anybody have any questions so far? All right. Got a little bit further here. So let's see, we'll just run through these. 1/3, so let's see, 1/6 would be 7 over 6 times 1/3, get 7 over 18. 3 1/2 is 7/2 times 4 over 9. The 2 turned into a 1, the 4 into a 2. We get 14 over 9, or 1 5/9. So this one would be 15 over 8 times 12 over 5. This can be a 1. 15 can turn into a 3. 4 goes into this 2 times. 4 goes into this 3 times. We're stuck with 9 over 2, or 4 1/2. 5 times 7 is 35. So we get 40 over 7 times 21 over 10. This is a 1, and this becomes a 4. 7 goes into 21 3 times. Left with 12 over 1, or just 12. Okay, so when we're using these in an example, right? This is a real life example. A city is resurfacing a basketball court. Find the area of the court. The area is the width times the height. So we have 21 and 1/3 times 13 and 1/2, right? So 21 and 1/3 can be 63, so 64 over 3 times 27 over 2, right? 2 goes into 64, we know, 32 times. 3 goes into 27, 7 times. 7 times 32 should be, let's see, 4. Add the 1, 22, 224 meters squared. Do you have a question, Jerry?
3 goes into 27 9 times.
3 goes into 27 9 times. That's right. My bad. I was looking at the 7. So 9 times 32 is 8. Add the 1, 27, 28. 288 meters squared. Thank you for that, Jerry. And so same, when we find the area of this one, it's the same. We have to multiply these through and then add them, okay? Or then multiply them. So now when we divide by fractions, our core concept, two numbers whose product is 1 are reciprocals. To write the reciprocal of a number, write as a fraction, then invert the fraction. So the reciprocal of a fraction, a over b is b over a. A or b cannot be 0. Did you have a question, Jerry? Okay, so now we're going to write the reciprocals. Jerry, what's the reciprocal of 3 over 5?
5 over 3.
5 over 3. Alina, what's the reciprocal of 9 over 5?
5 over 9.
5 over 9. Max, what's the reciprocal of 2?
1.5.
So 1/2. So 2 is 2 over 1. The reciprocal is 1 over 2. Does that make sense?
Uh-huh.
Okay, perfect. Kevin, what's the reciprocal of 3/4?
4 over 3.
4 over 3. Maggie, what's the reciprocal of 5? So what is the reciprocal here? Does this make it easier? What's the reciprocal of 5 over 1?
1, 5.
1 over 5. Perfect. So any number that's just a number, just put it over 1, and then you just flip it. Nicole, what's the reciprocal of 7 over 2?
2 over 7.
2 over 7. And Amber, what's the reciprocal of 4 over 9?
9 over 4.
9 over 4. Perfect. So that's easy stuff. So dividing a fraction by a fraction, order of operations with exponents. Dividing fractions. To divide a number by a fraction, multiply the number by the reciprocal of the fraction, right? So if we have 1 over 5 divided by 3 over 4, we take 3 over 4 and use the reciprocal. And so then it becomes 1 over 5 times 4 over 3. So if I have 1 over 6 divided by 2/3, I do 1 over 6 times 3 over 2. And then I can still do this cancel, right? 1, 2 to get 1/4. So Jerry, what's the reciprocal of 1/3?
3.
3. So 3 over 1. So we get 6 over 7. What's the reciprocal of 1/8, Alina?
8.
Perfect. 1/4. What's the reciprocal of 1 over 4, Maggie?
So 1 over 4 would be 4 over 1.
Perfect. Or just 4. 3 over 2 or 1 1/2. What's the reciprocal of 3/10, Kevin?
The reciprocal of 3/10
Yep.
is 10 over 3.
10 over 3. Perfect. So 1 and 2. 4 over 3 or 1 1/3. All right. And so when we're doing it with whole numbers, right? So like we'll look at this example. A piece of wood is 3 feet long. How many 3/4 foot pieces can you cut from the piece of wood? So 3 divided by 3/4, right? It's the same as 3 times 4 over 3. Well, 3 is actually equal to 3 over 1. Oops, 3. And so now we can cancel these out. They'll become 1, so we can make it 4 equal pieces. Does that make sense? Perfect. So this one, how many 1/2 foot pieces can you cut from a 7-foot piece of wood? Go ahead, Jerry.
14.
Perfect. So we do 7 divided by 1/2. And so 7 over 1 times 2 over 1 equals 14 over 1, which equals 14. Alina, how about this one here? What do we turn 2 into?
1/2.
Perfect. And what do we get here? 2 over 5?
Yeah.
Perfect. All right. So we'll divide, then write in simplest forms. And so you guys know how to do these now, right? So 1/2 divided by 3 times 1/3, 2/3 times 1 over 10. This one would be 5/8 times 1 over 4. And this one's the same, 6 over 7 times 1 over 4. Order of operations. Evaluate 3 over 8 plus 5 over 6 divided by 5. Alina, what would we do first?
5/6 divided by 5.
Perfect. So we do 5 over 6 times 1 over 5, because that's how we change it. And so we end up getting 1 over 6 plus 3 over 8. So then we have to get a common denominator and add them, right?
Yeah.
So same with these ones. When we're looking down here, evaluate the expression and write in simplest form. 4 plus 5 plus 2 over 5 divided by 4. We still do division first, so 2 over 5 times 1 over 4, then plus 4 over 5. What about this one? What do we have to do here, Nicole? What would we do? 3 over 8 plus 3 over 4 minus 1 over 6.
I'm going to do 3 over 8 plus 3 over 4 first, and then
Like that,
do
first and second. So this one, since it's just addition and subtraction, it doesn't matter which one you do first. I would do this one first because our common denominator is going to be 8. I would do whichever one looks easiest first. So what about this one, Nicole? For C, which one would you do first?
it doesn't matter, but
Perfect.
I will do the first one first.
You would do the first one? See, I would probably do 2 divided by 8 first, right here. 2 divided by 8 creates a fraction. And then we can do 8 over 9 times 4 over 1. That's what I would do. But that's it for today. And so there's homework on the lecture on Google Classroom. And then come next time with questions on homework if you have any. And I'll put the answers up for everybody, and I'll put the next lesson up. Okay? Any questions?
Did you record this?
Yeah, it's my boss has been recording these for their information.
Okay.
Not me. So any other questions? Awesome. Okay. Well, I'll let everybody go. And I hope you all have a great rest of the weekend. Bye, everybody.
Bye.
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 Can't leave.
Bye.
Bye. Thank you.
Thank you.
My leave
Bye.
button isn't working. Is
That's
there a way you
okay.
can kick me?
I'll kick you out. See you
Okay,
later.
thank you. Bye.